All right, hi guys, thanks for joining me today. I know quite a few of you have KC testing on campus, so some of you were not able to make it live, but I am grateful for those of you that are here. I put up this little activity on the screen and it says, here's a creepy activity. Can you find the man in the coffee beans? So if you don't want to see the answer, pause the recording real fast and look for him, and then I'm going to point him out to you in just a second. So it's actually his head, and he is right here. Okay, so if you look at him, you can see his nose is right there with his forehead right here. Can we kind of see him now? Eyes, nose. It's an actual person's head. So interesting. I'll let you come up closer and check him out a little bit later. So today what we're doing is we're checking on through Unit 3. Please have your formula sheet handy. I know that I emailed it to you guys last week. Let me file transfer it again. So grab your formula sheet if you don't have it handy, because I want you to have it. Actually, I don't have it handy right now. I'll add it right at the very end today. So what we're going to do is we're doing a Unit 3 review. We're going to do arithmetic and geometric series and sequences, and then we're mainly focusing on summation this week. So here is your week 10 essential question. So whether you are in person or at home, please take a quick minute and copy that down. Okay, so for week 10, your essential question is, what are some key features of the summation formula? So I'll be walking you through the formula and pointing different things out about it. So your essential question is just to describe the summation formula to me. What do all the little parts and pieces mean? So by the end of today, you'll be able to answer that question. So last week what we did was sequences. We worked on arithmetic sequences and geometric sequences. So just quickly to remind ourselves, an arithmetic sequence looks like this. 1, 3, 5, 7, dot, 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 dot. Geometric, I'm going to change colors, is like this. 2, 4, 8, 16, dot, 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 dot. So what were the key differences again? Arithmetic does what? From one to the next, what are you doing?
You're adding or subtracting.
Good, you're adding or subtracting. Geometric, what's the difference? Multiplying or dividing. So that's what we learned last week. On your formula sheet, let's highlight just a couple key pieces of each formula. So under arithmetic sequence, can you guys circle or highlight the D? That is the only piece of the puzzle you needed to find, right? Everything else stays exactly the way you see it. Iterative rule, same thing. The D we're going to fill in, but then also A sub 1 gets filled in. So let's remind ourselves what some of this terminology means. A sub 1 means the first term, right? That's what the little 1 is for, first term. And D would be the common difference. D is common difference. In the geometric sequence, you're going to fill in your R. R stands for your ratio. And on the iterative rule, we'd fill in the A sub 1 and the R. Everything else stays the same. Last week I had you guys put a big star next to one of these rules because I said this one's much more useful. Do we happen to remember which one we said was much more useful than the other? Iterative rule is more useful because iterative rule lets you use any number you're trying to find. So if I want to find the 100th term, n would be 100. N would be 100. Recursive rule, you always have to know the previous term. Remember we said A sub n minus 1 is always the term right before? So that means if I want to find the 100th term, you'd have to know the 99th term to use this rule. Most of the time we don't know that. Again, most of the time we don't know that. So this one is not nearly as useful as the iterative rule. Last week up on the board, we were practicing putting up some of our sequences. And we made one little mistake, and I want to put it up here and ask you what the mistake is. It was this, 1, 12, 24, 36, dot, 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 dot. So let's think about what rule this is. I see adding 12, but I made a mistake somewhere. I'm going to highlight it. How do you go from 1 to 12? Do you add 12? Oh, so I made a little mistake with that one. What number should this sequence have started with? A 0. Good job. Now my rule would be add 12, add 12. Everybody okay with that? So I just wanted to point out one key thing that we made a little mistake on at the end of last session when we put that on the board when you guys were designing your own sequences. So today is all about series. So how is a series different than a sequence? A series has a set amount of numbers. You guys see that? My sequences were always like this. 1, 2, 3, 4, dot, 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 dot. That's called a sequence. These are called series. So let's look at some of my differences. A series has a set amount of numbers. And what else is going on? What's between each of them? A plus sign. Okay, interesting. So a sequence is just a numbers in order with a pattern, right? There's always a pattern. Dot, 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 dot means it keeps going forever and ever. A series is a set amount of terms. So that's the difference today. We are going to practice writing equations for series today. Last class, a week ago, we were dealing with sequences. Today we're dealing with series. So you guys grab your formula sheet. You guys see the top 2 were formulas for sequences. The bottom 2 are formulas for series. So we're going to be working on the bottom 2 formulas today. Everybody okay? There's really 4, right? 2 for arithmetic, 2 for geometric. So we're working on the bottom half of my worksheet today. So here's how we start. To write a series, we're going to use sigma notation. Can you guys underline that word sigma notation in your notes that you guys printed out? Sigma notation. There's a Greek letter for sigma. You guys have heard of all those crazy fraternities, sororities that use all those Greek symbols, right? Sigma, it's kind of like an E. Go ahead and write in your E symbol. So anytime we see that sign, that sigma series, that's going to equal, we're talking about a series. That's cool. So anytime you guys see that symbol in your notes, on a quiz, on a test, you're talking about a series. So what formulas are we going to use? The bottom half of my worksheet. Anytime you guys see that symbol. So on our worksheet, can we add that little symbol on my worksheet at the bottom half? So there's a couple steps in order for us to write a series, and there's just like before, just like last time. We're going to have to identify the first term, which we know is always a sub 1. Go ahead and write that in there. Going to identify the first term, which is a sub 1. How can you find it? It's always the very first term. Next, we're going to identify the type of sequence as a difference or a ratio. Let's underline those words. Difference or a ratio. So if it's a difference, that is what? Arithmetic sequence, series. And if it's a ratio, then it's a geometric. So a ratio is geometric and difference is arithmetic. Right? Meaning adding and subtracting, or are you multiplying or dividing? Step 3, we're going to write the iterative rule for the sequence. And then lastly, we're going to use sigma notation. So all of this is going to make more sense when we try one in just a second. So let me show you one. So let's check out this crazy symbol. This is kind of new. I'm going to use my pointer. So here's my sigma notation. I is what term you're starting with. So we're always going to start with our first term for right now. And n means how many total terms I'm doing. So this won't make sense when we try one. Don't freak out on me. This is called the lower limit at the bottom. This is called the upper limit at the top. So if I want us to find the sum of the first 5 terms, I would say between 1 to 5. If I wanted the sum of the first 10 terms, I would say 1 to 10. We're going to try one, but this is just the general look of what it's asking to do. So what does this sigma symbol really mean? It means the sum. That's why when you guys see a series, there's always that plus sign in between all the terms. What are we going to be doing to our terms? Adding them. Every single time we're adding terms together. So sigma means sum. Let's circle that word sum. We're always going to be adding up our series together. You may be thinking, okay, this looks a little crazy. I don't really know what she's asking me to do. So now let's try one with numbers now that we've sort of talked about the general rules here. So here's my example number 2. It says write each series in expanded form and find the sum. So watch what I'm going to do. My lower limit is a 1. My upper limit is a 4. So this means I want to find the sum of my first 4 terms. Everybody okay with how I read that? Wants me to start at 1 and it wants me to go to 4. I have to add the first 4 terms together. Here's the equation for my sequence. Because remember, sequences don't always have to say plus 1, plus 1, plus 1, or times 2, times 2, times 2. Series can get a little more complicated than that. So watch what we're going to do. We're going to take the 1 and plug it in for k. So let's all do that. So 3 times 1 minus 1. This is me starting with a 1. So 3 times 1 minus 1 means 3 minus 1 gives me 2. That's your a sub 1 term. That's your first term. You guys did a great job. Now it wanted me to start at 1, but then where does it want me to go? All the way to 4. So what comes right after 1? What would be my next term I have to try? I have to try 2. So let's take the same thing again, but now I'm going to plug in a 2. So 3 times 2 minus 1. So 6 minus 1 gives me 5. That's my a sub 2, your second term. Where do you think I'm going from here? What am I going to plug in next? A 3. So 3 times 3 minus 1. So 9 minus 1 gives me 8. That's your a sub 3, your third term. And lastly, they want me to try a 4. So I have to do 3 times 4. Sorry, I totally ran out of space. Plus 1. So 12, oops, minus 1. 3 times 4 minus 1, there we go. So 12 minus 1 gives me 11, a 4. So we plugged in a 1 for k, then a 2, then a 3, then a 4. Now it wants me to write an expanded form, which is what I just did, but then what does it else want me to do? Find the sum. Let's circle that word sum in my direction. So that means I'm going to put big plus signs between all of these terms. So 2 plus 5 is 7. 7 plus 8 is 15. 15 plus 11, 26. Okay, so let's look at this one more time. What did it want us to do? This sigma notation means add up all the terms together. Which terms am I adding together? Between 1 to 4. So I had to find 1, had to find 2, had to find 3, had to find 4. Then I am summing up those answers to give me the sum of the first 4 terms. You guys did great. We're going to try again. First time's always a little like, ooh, this is new, kind of strange. We're going to try again. So on the next example, it wants me to write an expanded form and find the sum. So before I start, let's look at some of the key parts of my sigma notation. This is part of your essential question. So when I'm looking at sigma, what are some key features you guys see? Where does it want me to start? The 1. And I have to go to 5. What am I going to do with 5 terms? I'm going to, after I find term 1, term 2, term 3, term 4, term 5, what do I do with all 5 answers? I'm going to sum them all together. So let's start with p equals 1. So I'm going to take my formula and I'm going to plug in a 1. I'm going to start on the left side of this slide so I don't run out of space. So first, I'm going to plug in a 1. And watch how I solve these. I'm going to write all 5 terms first, then I'm going to go back in and solve each one because for me it's like a pattern, right? So I plugged in a 1, I'm going to plug in a 2, I'm going to plug in a 3, 4, and a 5. For me, it's easier once I get in my mode of writing them all out. I'm kind of in my sequence mode where, hey, I'm just going to fill in my 1 through 5 right now. So the only part of this problem that's changing, I'll highlight it. We're just changing P. P is a 1, then P is a 2, P is a 3, P is a 4, P is a 5. Let me give you guys just a moment to try and find each of those terms and then add up those terms. We just have to remember order of operations. So you guys are going to do your parentheses first and then square it. So 2 squared is going to give me 4. So my a sub 1 is 4. 4 squared is going to give me 16. 6 squared is 36. 8 squared, 64. And 10 squared is 100. This sigma notation always means to do what with all of your terms? Add them. So see how I'm writing my final answer? I'm saying the sum of terms 1 through 5 equals, and I'm going to put my answer right there. That's all this symbol means. I know it looks kind of crazy and scary, but it's actually really easy. So again, the sum of terms 1 through 5, which means I'm really adding 5 things together, was 4 plus 16 plus 36 plus 64 plus 100, which is going to give us 220. Final answer. So these are what are called straightforward problems, meaning they're giving you the formula and they're telling you what to plug in. They're saying plug in from 1 through 5. Pretty straightforward. Guess what we're going to do now? Now I'm going to give you the series and we have to write this. Okay? If we can do it one direction, we can take the answer and work our way backwards. Are we ready to try? You guys are doing great. Oh, by the way, let's look at these. This one would be considered a, look at my terms, plus 3, plus 3, plus 3. So this one was an arithmetic. Look at this one, 2 times. So this one would be a geometric. Okay, just pointing that out. There's 2 different kinds always, just like on our paper. Now that we're going to write our own, there's 2 different kinds. Okay, so here we go. We are going to write our own. Step number 1, we need to determine, so I'll write my E. There's my sigma, there's my E. Your I always starts at the first term. So far, is everybody with me? Okay, start off with our first term. The top is how many total terms you have. Can you guys count up how many total terms am I adding together in this series? How many are there? 9. Great job. That's your upper bound. Everybody okay so far where those 2 numbers came from? So I'm starting with my first term. How many total terms am I adding together? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So far, we did great. Now I'm kind of missing the crux of my problem, which is the equation for it. So what we have to determine, I'm going to put arithmetic or geometric. We're going to circle one of those 2. I need you guys to look for the pattern. How do I get from one number to the next number, one number to the next number, one number to the next number? What's happening? What's your pattern? Adding 2. What kind of sequence does that mean it is? Perfect. Can you guys circle that word? And let's cross off geometric. you have to recognize what kind it is, because if you guys look on your chart here, do you see how the formulas are different for arithmetic and geometric? They're different. So I have to recognize which one is it to know which one to use. And we are going to use, so we know it is arithmetic. Oh, we're still writing the sequence rule. That's handy. Okay, so the sequence rule, we're actually still up at the top now. So look up at the top of your paper. We're going to use the sequence rule. I'm going to come back here to the steps real fast. That way if you forget on your own, they're here in your notes. So we're going to identify the first term, which we can easily do that in a moment. Pick the kind of sequence it is. So we're picking arithmetic. And then it says write an iterative rule for the sequence. So it's giving us that step. So everybody go up to the top, find iterative rule under arithmetic sequence. So what's my iterative rule? It says a sub 1 plus n minus 1 times d. Can you guys write that in next to yours? So a sub 1 plus n minus 1 times d. So we have two things we need to fill in, and then we are done. We need to fill in my a sub 1. We need to fill in my d. See if you guys can do that step. Yes, so the question is there a reason we're doing the sequence formula instead of the series? And the answer is yes. So I'm going to show you the difference in just a minute. It just depends on if they're asking you to add up all the terms or if they just want you to write the series. If they just say write the series, we're going to use the sequence formula. So if you want to highlight that like on your paper, if they say write each series, you're going to use your sequence formula. I'll make sure it's crystal clear before you go, the difference between the two, because we're going to do one of the other ones in just a second. Let's fill in my numbers now. So a sub 1 is going to be what numbers on your chart? What's your first term? 5. And minus 1 stays. What did you guys already tell me is your difference? Positive 2. Right, we said that over here. So what do you think I have to do to simplify this formula? You're so close to being done. What do I have to do? This looks weird. So what do I have to do with that? You are right. I have to distribute. I'm almost done. So I'm going to get a 5 plus a 2n minus 2. I'm just distributing it, right? Just getting rid of that parenthesis. No big deal. Now what else can I do to simplify this? One last step and you're done.
Combine the minus 2 and 5.
Perfect. So 5 minus 2 gives me 3. So my final answer for representing this series that we see up there on the screen, we're starting at 1, we're going to 9, and then this would be your formula. So we just did it backwards. You guys did great. Remember in the last problem, we would have taken the 1, plugged it in, gotten a 5. Taken the 2, plugged it in, received a 7. Taken the 3, plugged it in, received a 9. So what we did is we took our series this time and we are changing it into the formula. So we're just working our way backwards. And we're going to try again in just a moment. So what are the key pieces? Identifying if it's arithmetic or geometric based on my pattern. Since it was plus 2, we know that plus 2 matches arithmetic. So we looked at my chart and we're always going to be using iterative rule here. I'm actually going to make a little note of that too. Can you put iterative at the top? So anytime it says write each series, we're going to use the sequence formulas and the iterative rule. So one more reason to have that side of our paper starred, right? It's much more useful than the other side. So that was our first example. Now we're going to try one more time to take the series and write the formula. You guys are going to get this one. This one's going to be easier. Okay, so example 5. Write this series using sigma notation. So write this series means we're going to use my sequence formula. iterative rule side, iterative, there we go, iterative rule, so there's a couple things I need to identify. Everybody start with their sigma sign. Here's my big old E. We're starting with our first term. And how many total terms am I going to be adding together? Can you guys count that up? 7. Fabulous. Great job so far. Now I need my formula in here. Before I can add my formula, I have to ask myself, am I talking arithmetic or geometric? So let's see what my pattern is. How am I going from one number to the next number? What's happening? We're multiplying by 2. When we multiply, is that arithmetic or geometric? Geometric. Great job, guys. So everybody look at your chart. We're at the top. Geometric sequence, iterative rule. Can you guys write out the iterative rule? So I'm looking at the top, geometric sequence, iterative rule. So my rule is a sub 1 times r to the n minus 1. I'm filling in 2 numbers here, my a sub 1 and my r, and then I'm finished. So let's try and rewrite this thing. Here's my sigma. My a sub 1, everybody says, is what number? 1. What did you guys, are you guys okay with a sub 1? First term, right? You look in your number sequence, the very first term. My r, what did we say the ratio was from one number to the next? What's happening? So 2, good job, to the n minus 1. You are done. You're done. That's all we need to do. You guys did great. Now, because it's a 1, you don't have to have the 1 times the 2 in there. Does that make sense? Because it's just a 1. It's not going to change anything. So to finally totally simplify it, this is how it would show on a quiz or a test. It would just say this. So if I ask you, what are some key features of this formula, you're going to tell me it tells us where to start. The 1's called the lower bound. It's saying start at 1. What term are we going up to? 7. We're going to add all those terms together. That's what that little sigma sign means. So I'm going to add term 1 plus term 2 plus term 3 plus term 4, 5, 6, 7. We're adding 1 through 7 together, and there's your formula for it. Let's try it and see if it works right. Let's try plugging in a 1, because if I plug in a 1 here, I should get 1. Let's see. If I plug in a 1, 1 minus 1 is 0. What's 2 to the 0 power? 1. Let's try plugging in 7. Let's see if that gives us our last term. 7 minus 1 is 6. 2 to the 6, yes, it's 64. I know that one was harder to do in our head, but 2 to the 6th power, it really is 64. You guys did a good job. So you can always check to make sure you did it correctly. Any questions so far? So what we've done so far today is I've given you the formula and we've found all the terms. And then I've given you the terms and we've found the formula. So we've been able to go backwards and forwards, both directions. Now some of you are asking me, well, when are we going to use those formulas at the bottom? The formulas at the bottom are for when you want to find the sum of the series. So at the very bottom, do you guys see how in all those formula boxes it says S sub n? Guess what S stands for? Sum. Can you write that in on your formula sheet? So at the bottom, where it says S sub n, which is right here, I also have it on the screen, anytime you see this S sub n, that means you're going to be summing up the terms. You're just going to sum up the terms. You're going to see how this is different from what we just did in a minute. So S sub n means we're going to be summing up the terms. They give you 2 different formulas here. The formula that is on your left-hand side, this is when you know your first term. Everybody okay with a sub 1, right? Your first term. A sub n is going to stand for your last term. Can you write that down for me? So on your formula sheet, we're on our left-hand column under arithmetic sequence. It says a sub 1 we know is our first term plus a sub n. A sub n is going to be your last term. So let's try it. You're going to see how this works. So for instance, if I asked you to add 1 plus 3 plus 5 plus 7, if I wanted you to add those together, we could use this first formula. I know you guys have some lines next to this slide if you guys could practice this one with me. What this is saying is my sum is going to equal n divided by 2. N is your total number of terms. How many terms do you guys see up there? 4. Then I'm going to multiply by my first term plus my last term. What's your first term up there? 1. What's your last term up there? 7. So this says to find the total sum of all 4 of these numbers, I'm going to take the total number of terms and divide by 2. I'm going to get 2. And 1 plus 7 is 8. 2 times 8 is 16. What that's done for us is it's giving a formula that's going to let us add all 4 of these terms together. So 1 plus 3 is 4. 4 plus 5 is 9. 9 plus 7 is 16. This formula lets you add that whole series together. Now you may be saying, Ms. G, that is a lot of work for something that has 4 terms. Well, what if we had 1,000 terms? Do you really want to add all 1,000 terms together? No. You want a shortcut method to add all those terms together, and this formula is going to help us do it. So one more time, what did I do? Total number of terms, that's n, right? N is total number that you see. We saw 4 things. You always divide by 2. And then inside your parentheses is your first term plus your last term. Handy. Super handy. That gave us my answer. So could you have added these 4 together in your head or on a calculator? Yes, you could have, and you would still get 16. I'm just showing you how the formula works in case you don't have like 1,000 terms or something crazy like that. They're giving you an alternate series right here. So this is an alternate formula that also works. We're going to try it with this one just to prove that it does give you the same answer. So here we go. So underneath this one, let's just try our numbers and make sure it works. So 4 divided by 2 times 2 times a sub 1. So my a sub 1 is a 1.
Ms. G, actually, I have a question.
Sure.
How did we find out that there were 4 terms on the first?
Oh, I gave it to you. I gave you these 4.
And
it has to give them to you. Yep, so that's how we found n, because I told you, or I'm giving you that there are 4 terms. So on this one, my a sub 1 is a 1 plus n minus 1. So n is a 4. 4 minus 1 times d. Now d again is your difference ratio. So everybody look up there. What's my difference? What's happening between these two? What's my difference? What's my pattern? Adding 2. So let's see if this crazy thing gives us the same answer. So 4 divided by 2 is 2. 2 times 1 is a 2 plus, that would be 4 minus 1 is 3. 3 times 2 is 6. So 2 times 8, 16. We got the same answer, which we should. These are 2 formulas that give you, see how this bottom one's called alternate? So they're 2 formulas that give us the same answer. So what we're going to practice on the next couple of slides is determining when are we going to use the top formula, when am I going to use the bottom formula. The top formula we're going to use if I know my first term and my last term, because wasn't this one a little more simple? Right, a little bit shorter. The bottom one, I only need to know my first term and then my difference to get to the next term. So I don't have to know my last term for the bottom formula. So it's 2 different scenarios. So let's practice examples of when I'm going to use each one. Here we go. It says, find the indicated partial sum of the arithmetic series. So notice the wording here. Partial sum If it says partial sum, those are your formulas at the bottom of your paper. So on the bottom of your paper, of your formula sheet, if you guys can write those words, partial sum. I know we wrote sum already down there, but these are also known as partial sums. So watch what I'm going to do. You don't need to write this part. I just want you to watch for just a second. There's formula number 1. Here's formula number 2. Let's see which formula I'm going to use. The first formula, I need a sub 1. Do I know that? Yep, they told me it's 2. Right, here's my formula. But then I need my last term. Are they showing you your last term? No, I can't use this formula. They're not giving me that number. See how it keeps going dot, dot, dot? How many did they show me? Here's 1, 2, 3, 4, 5. You guys see where I'm going with this? Dot, 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 dot. How many are they asking me to add together? 12. I don't know my 12th term. I can't use that first formula. I have to use my bottom formula. So let's all fill this in together, my bottom formula. So n divided by 2. N is the total number of terms they're talking about. So look back at the very beginning at what I circled. How many total terms are they asking me to add together? 12. So I'm going to say 12 divided by 2 times 2 times my a sub 1. So everybody look at your sequence up there. What's my a sub 1? 2. Now I have that n again, n minus 1. How many total terms are they wanting me to find? 12. 12 minus 1. The only thing I'm missing is d. Now d is your common difference. How do I go from 1 to the next, 1 to the next, 1 to the next? What's happening? Adding 1.5. Great job. You guys did excellent. So all I have to do is figure out that equation, and that's going to be the sum of my first 12 terms. So let's figure it out together. 12 divided by 2 is 6. 2 times 2 is 4. 12 minus 1 is 11 times my 1.5. 11 times 1.5 gives me 16.5. It's okay to use a calculator at that point. So this would be 6 times 4 plus 16.5, or 6 times 20.5, which comes out to be 123. So we would write our final answer like this. The sum of the first 12 terms is 123. This right here is the same as 6 times 20.5, and if you did that in a calculator, you get 123. You okay with that? Because 4 plus 16 is 20, right? So try it. 6 times 20.5, you get 123. Okay. Just making sure we're all on the same page. So if it asks me to find the partial sum, we're talking about the formulas at the bottom of the page. How do I know what formula to use? It depends on, do we know my a sub n? Meaning, do you know your last term? Or do you not know your last term? If we know our last term, we're definitely going to pick the top one because it's way, way easier. I know my math scares everybody away. Bye, Mrs. Burke. So if you know your a sub n, you're going to pick your first equation because it's way easier, right? Much more simple than the bottom one. The bottom one you can use all the time. So if we're looking at my two formulas here, the right-hand side you can use all the time. The left-hand side we can only use if we know our last term. So if we want to circle this left-hand side and say only if you know your last term, that would probably be a good thing to note on your formula sheet. So the left-hand side of our formula sheet is only if you know your last term. The right-hand side, you can always use that side. When are we using the bottom? When we're finding a sum of the digits, or a partial sum. So the bottom is for the sum or the partial sum. How else do I know I'm finding the sum? They're going to do that capital S. Capital S means we're summing those up. How many was I summing up in this example? My first 12 terms. So notice, I didn't even have to find my other terms to be able to add them. The formula did it for us. Isn't that so cool? I could have set 1,000 in there, and we still could have found the sum of the first 1,000 terms. Pretty awesome. We're going to try again. Notice that this time, this one was an arithmetic series. It told us that in the problem, but I knew that anyway, because adding 1.5, what kind of is that? What kind of sequence is that? It's adding, right? So that would be arithmetic. So this time, we are going to try it this way. This is a slightly different way of saying the same thing. I'm just giving it to you in a different format. And I know this format looks a little scarier, but it's actually easier. I'll show you why in just a second. So it's still telling me that it's an arithmetic series. So let me show you my two formula options. I'm looking at my paper. I'm looking at the bottom. I can use this one. Or I can use this one. So here's what we have to ask ourselves. Do you know your first term? And the answer is, kind of not yet. I need A1 in both of them, correct? How am I going to find my A1 if they give me this? What do I have to do? Think about it.
5 times 1 minus 6.
Perfect answer. Good. So if you want your first term, guess what I have to plug in? A 1. That's your first term, right? Taking a 1, plugging it in, that's your first term. So let's try that. Let's all find my A1 together. A1 is where I take my formula, and I'm going to plug in a 1. Remember when we did this at the beginning, but I made you plug in the 1, and then the 2, and then the 3, and then the 4, and then the 5. We did this already, but this time it's on a much smaller scale. So my A sub 1, sorry, that's a multiply. So 5 times 1 is 5. 5 minus 6 is a -1. Hey, I found my A1. I had to find it myself, but I was able to do it. So this time in both formulas, I know my A1. So here's my dilemma. To use the top equation, I need my last term. To use my bottom equation, I need to know the common difference. We like the top one if and when I'm ever able to use it. So the question is, are you guys able to find the last term? Yeah. What do you have to plug in to find your last term?
5 times 3 minus 6.
You have to plug in the 30. Good job. So let's find my last term. Let's all find A30. To find A30, I'm going to take my formula, and instead of the I, I'm going to plug in 30. So this would be 150 minus 6, so 144. That's your A30. Awesome. We like the formula better. We just do, because then you know your first term and you know your last term. You just have to find them by plugging it in. So let's take them and plug them in. So here's my A1, -1. Here's my A30, which is 144. We get to use this top equation, which is so much easier. I'm going to rewrite it in a different color. That way we all know where I'm at on my paper. So here we go. We're finding the sum of the first 30 terms. So my n is 30. I don't know if you've noticed, but every time I use a formula, I like to have my blank formula first, and then I fill it in right underneath it. So yes, I'm writing my formulas 10 million times, but it helps me not make a mistake. So my n is 30. We said that my a sub 1 was -1. And my an means your last term. What was my last term? 144. Exactly. So this would be 15 times 143, which using a calculator, totally fine, 2,145. That is your first 30 terms added together. Because think about it. Could you have done this by hand? Yeah. You could have plugged in a 1, a 2, a 3, a 4, ... all the way to 30, and then added all those together. So that's a huge waste of your time. So the formulas at the bottom of your page are helping you sum up. Remember that big S? It means summing up. You're summing up those total numbers and getting a final answer. So what's the difference between the top part of your worksheet paper and the bottom? The bottom is summing up your terms. What's the top part doing? Writing rules or writing equations for them. See the difference? The bottom, summing up your numbers. The top is when they want the formula. Okay, so there's a difference between the two. Keep them straight because they have an S at the bottom. S means sum, right? Meaning total. You're going to total them up. Okay, I have one more kind to show you and then we're going to call it a day. So far we've been working with the arithmetic series. So arithmetic, arithmetic, arithmetic. Guess what kind we're going to try now? Geometric. So your geometric series, again, these are the two at the bottom of your paper still. You have two different options. Let's talk about my options. The bottom one you can only use if you know your last term. Isn't that really similar to the arithmetic ones too? There's two terms. The top one, all you need to know is your a sub 1. The bottom one, you have to know your last term. So this one we can use sometimes. This one we can use all the time. We like the bottom one if we're able to, but we don't always know our last term. So again, the top one we can use always. The bottom we can only use sometimes. Just if you know your last term. I'm even going to write that on there. Just if you know your last term. So here I'm giving you an example. I want you to find the partial sum of this geometric series, and I'm asking you to find the first 10 terms. So let's look at my two options. I'm going to write out these two. You don't need to write them. You can just watch with me. There's option 1, or here's option 2. So the question is, do you know your last term? A sub n is always your last term. They want the first 10 terms. Do they show you the last term or do they not show you the last term? They don't. If they don't show it to you, you cannot use any of them that have that a sub n in it. That's the key. That's all you need to keep in mind as you guys are doing your homework. Do you know your last term or do you not? If you don't know it, you cannot use that formula with the a sub n in it. So let's all try this first formula. We're going to plug in my numbers here. So I'm going to say it's the sum of the first 10 terms. So are we okay with my n becoming a 10? Because it's telling me 10 terms. I need to fill in my a sub 1. So out of my formula, where's my first term? It's a what? -2. Great job. 1 minus, ooh, I need my r. They're telling me it's geometric, so I have to ask myself, how are they going from 1 to the next? 1 to the next, 1 to the next. Okay, and if we can't see it, we had a rule last week on how to find it. You could take a number, take any term you want. Let me change colors here. So we're going to take the -1 and you divide by the term in front of it. What's -1 divided by -2? 1/2. 1/2 is your ratio. Let's see if that makes sense. Is -2 times 1/2 -1? Yeah. Is -1 times 1/2 -1/2? Yeah. 1/2 times 1/2 1/4? Yes. So that's how you can find it. If you can't see it, and I know most of the time we can see it, so it's kind of frustrating if we can't, you take one term and divide it by the term in front of it, and that's how you find that ratio. So my r this time is a 1/2. And then it's supposed to be raised to the n. So that means it's going to be raised to the 10th power. Divided by 1 minus r. This you are definitely going to do in a calculator because you're not going to do 1/2 to the 10th power on your own. That's crazy. So it's totally fine to use a calculator. Just make sure when you guys type it in, you're doing order of operations. So you would have to do exponents before you subtract the 1 minus that. Does that make sense? Have to do the exponent first. So by the time we solve the top, you're going to get negative 1.99, and on the bottom we would get 1/2. Because 1 minus 1/2 is 1/2. And again, use a calculator, type that in, we would get negative 3.996. So what is the sum of the first 10 terms? Negative 3.996. So a calculator, if you don't have one, you can use one on your phone. You can, if you tip it to the side, if you tip your phone to the side, you get a scientific calculator. Or if you just Google free scientific calculators, one will pop up on your computer. So it's not cheating. But what I need you to do is, can you practice and make sure you get this answer? That way you know you're typing it in the right order. Does that make sense? Because every calculator is a little different with the order you type them in. So just practice, make sure you get that answer. Let's try one more. And then we're going to call it a day. So here we go. So let me show you our two options for ones to use. I can use this first formula, a sub 1 minus r to the n, divided by 1 minus r, or I can use a sub 1. And don't think I have these memorized either. I don't. I use my formula sheet just like you're doing. It is not cheating at all. It's just knowing how to use it. Because I think you would agree, if you don't know how to use it, the sheet's not going to help you very much. So here's the difference. How do I know which one to use? I can always use the top one. Always. This is the left-hand side on your chart. You can always use the left-hand side. The bottom one we can only use if we know my last term. So here's my question. They want the first, interesting. They want the first 10 terms, but notice they're starting at 2 this time. Oh, that's different, but that's not a big deal. Can I find my last term? Yeah, I can find my last term. So I'm going to put a star by this one. So I still have 2 numbers to find. I need to find my a sub 1 and my a sub n. So let's find my a sub 1 first. What's the first number you're going to plug in? A 2. That's actually your a sub 1 term. There's never anywhere that says a sub 1 you have to plug in a 1. No. A sub 1 just means your first term. So what's my first term going to be? When I'm plugging in a 2. So let's all plug in my 2. So 5 squared is going to be 25. So please don't get it in your head that a sub 1 means you plugged in a 1. No, a sub 1 just means your very first term of your sequence. My very first term happens to be this time when I plug in a 2. No big deal. So I got a 25. So let's all go back to my chart. So I'm finding the sum of the first 10 numbers. My a sub 1 was 25. And now I need my a sub n. So this time my a sub n, what number do I need to plug in to find my a sub n? Good. I'm going to plug in a 10 because it just means your last term. So I'm going to plug in a 10 in for my I. And 5 to the 10th is going to be a humongous number. So it's going to be, wow, 9,765,625. That's on a calculator, so again, don't feel like you have to do that. So in my formula here, I did my a sub 1 minus a sub n is 9,765,625 times r. My r is my ratio. Ratio means how do you go from one to the next? It's telling it to you right here. It's just a 5. So in this case, my r is a 5. If you have a hard time seeing it, what you could do is just plug in a couple numbers to try. So if I plugged in a 1, I'd get 5. If I plugged in a 2, I'd get 25. If I plugged in a 3, I'd get 125. So how did I go from here to here to here? Times 5. So you can find it by trying a couple, or by you're just going to look at this number right there. 2 ways to find your r. Then we're going to divide by 1 minus 5. Because it's 1 minus r. So on the bottom would be 1 minus 5. These are crazy big numbers, so they're obviously expecting you guys to use calculators. So by the time I'm done, I get 12,207,025.
Are you sure about that? Or for that one, because 9 million times 5 is going to be. Oh, okay, after you divide it. Okay,
yes.
Sorry,
so this will be your final answer. So I know what he was saying. He's thinking, hey, that's going to be a negative number. But guess what? 1 minus 5 is also a negative number. So negative divided by a negative is going to give us a positive answer. Good job. So this would be 25 minus this 9 million times 5, so like big, huge number, divided by negative 4 gives us 12,207,025. So yes, you can use calculators at all times. They're not off limits. Please do. I mean, I would hate to see you try it without one. That would be bad news. So the key really is knowing which one do you use, and there's no wrong answer. It's just sometimes you're not able to use this second one, the bottom equation, if you don't know your last term. Because if you tried to plug in your numbers, you'd say, oh, I don't know my last term. So sometimes you know your last term, sometimes you don't. That's the only difference between the two formulas. So that kind of wraps up the day. So what did we practice today? We practiced plugging in numbers for my partial sums. We've practiced taking a series and writing this. We've kind of gone both directions, right? We've written the formula, and then we've used the formula. So your week 10 essential questions are, what are some key features, if I could talk, key features of your summation formula? Meaning, what does this symbol mean? What goes at the bottom? What goes at the top? What goes to the right? You're describing the key features to me, which proves to me that you understand what this formula does. So for those of you at home, I need you to describe all of these blank areas and what goes there. Also, what does the symbol mean? So all 4 things that are highlighted are what I need answers for in the Dropbox today. So there will be 4 parts to your answers. Thanks, guys. I hope you have a great day.